Okay, welcome you all to my video lecture presentation. Myself, C. Ashok Kumar, Professor, Department of EEE. And my course name is Electronic Devices and Circuits. And the unit name is Unit 2. The name is Diode Applications. So far we had seen the diode applications. First application is diode acts as a switch, how it is acting as a switch we had seen. And then how it is acting as a rectifier. Okay, how the diode is utilized in a rectifier, and we had seen different types of rectifiers, and then we had seen different types of filters. Okay, next application, diode application, is the clippers. So clipper application we need to discuss now. The overview of my presentation goes on like this. First, you will be discussed about the types of clippers, basic clippers, positive and negative clippers, and then I will be explaining the positive biased clipper and negative biased clipper. Okay, the operation, and then I will be recapping the things whatever I discussed. And these are the textbooks I refer. And first of all, what do you mean by clipper? Clipper, as you can see here, this particular blue wave is the input signal. Okay, from the input signal, I want to remove some portion of input signal like this. Okay, so I want to remove this portion of my input signal. Okay, why? Because in some electronic applications, in a communication applications, whenever the signal is propagated through the channel, the signal will be getting contaminated whenever it is traveled through the channel by noise. That means, as you can see, this is the signal. As you can see, the contamination I'm showing here. The signal is contaminated here in this particular portion. Positive peak, some portion, negative peak, some portion, positive peak, some portion, like that. So I need to remove this portion from the signal. Okay, I need to remove this contaminated portion of the input signal. Okay, so that is nothing but a clipping. I need to remove my wanted portion of the given input signal. Okay, as you can see here, red is the output and blue is the input. Okay, so this type of application uh, will be done by making use of a clipper circuit. Okay, that's why the definition goes on like this. A circuit which used to remove the peak of the wave is called as a clipper. Peak of the wave is called as a clipper. As you can see, this is the peak, positive peak and negative peak, positive peak and negative peak. So it can be the positive peak totally it can be removed, and negative peak totally can be removed. In some cases, I need some portion of positive peak to be removed. Whatever may be the thing, removing a portion of the wave is called the clipping action. A circuit which does that is called as a clipper, right? And practically, if you see the nail cutter in your house, we will be using the nail cutter, and suppose the nail is like this. If I want to remove this portion of this nail, that particular portion will be clipped by making use of nail cutter. This will be removed. Okay, in that same manner here. So this is the signal I got. I need to remove this portion. I need to remove that portion. I need to clip that portion by making use of available electronic circuit, that is called as a clipper. And the main component that is used in the clipper circuit is, once again, it is a diode. Okay, so this is about the introduction. It is nothing but comparing our clipper circuit with a nail cutter. That will be a well-known example to you. Nail cutter means it removes whatever the portion of the nail you want to remove. Okay, the same manner here, I am using a electronic circuit to remove unwanted portion of the signal. That is called as a clipper circuit, right? So if you go for the classification, basic classification, they are divided into two types. One is the positive clipper and second one is the negative clipper, right? One is the positive clipper and second one is the negative clipper. What do you mean by positive clipper and what do you mean by negative clipper, right? So here, this is the input signal. Input signal, it is an AC signal. This is a positive half cycle and negative half cycle, positive half cycle and negative half cycle. And the peak value is plus V and negative peak is minus V, right? So this I am giving as an input to the circuit. And if you observe the output here, these are the output terminals. Okay. So as you can see here, the positive peak is not there in the output signal. Okay. So this portion is not there. Actually, this portion must be there, but it is not there, right? Okay. Similarly here, the second cycle, same thing here. Actually, the positive peak must be there. That is not there in the output. So that's why here it is called as a positive clipper. That means positive peaks are removed here. Okay. They are clipped here. So that's why it is called as a positive clipper, right? And the circuit diagram is like this. As you can see, the main component here is a diode and a load resistance RL, across which the output voltage will be taken. And similarly, negative clipper. In the negative clipper, what happens? As you can see, these are positive half cycle, negative half cycle, positive half cycle, negative half cycle. Negative half cycle will be clipped here. As you can see here, actually here the negative half cycle must be there, and here negative half cycle must be there. So by making use of this circuit, in which the diode is the main component, if you observe, if you provide this as an input, the output will be observed like this. In the output, as you can see, the negative peak is clipped away. It is not there. So that's why it is called as a negative clipper. And next, about the operation, positive clipper. Positive clipper, first kindly keep in mind that the positive peak will be removed here. So whenever this is the input voltage, the output voltage must be like this. Okay. That means here, this positive peak must not be there. As you can see here, positive peaks are not there in the output signal, output voltage signal. So how it happens, let us see here. So here I am providing the input voltage, and here I am taking the output voltage across the output terminals. This is the input voltage. Okay, input voltage will be looking like this. This is the positive half cycle and this is the negative half cycle. Okay, during the positive half cycle, what happens? Let us see through the operation here. So whenever Vi is greater than 0, that means during the positive half cycle. So what happens here? This is a diode and this is the anode and this is cathode. Whenever cathode is more positive, whenever Vi is greater than 0 means the meaning here is cathode is positive when compared with anode. So that's why what happens to this diode? Diode will be reverse bias. Reverse bias means it acts like a open circuit like this. Okay, it opens. That means no current will be flown through the diode through the load resistance RL. That means current is equal to 0. Then what happens to the output voltage? Output voltage is equal to 0. Okay. So whenever Vi greater than 0 during the positive half cycle, what happens here? Output voltage is equal to 0. So that's why here, as you can see, output voltage is 0. Okay. So during the negative half cycle, what happens? Let us see. During the negative half cycle means here this will be V0. Negative half cycle means this becomes minus and this becomes plus. Cathode, this is anode, sorry, this is anode and this is cathode. So cathode is at lower potential when compared with anode. Cathode is at lower potential when compared with anode. Then what must happen to this diode? Cathode is at lower potential when compared with anode. Lower potential in the sense here, as you can see here, I am giving an example. So this is anode and this is cathode. So here I am giving 5 volts and here I am giving 3 volts. What happens to diode? Diode will be forward bias. And here, so what happens here? Here I am giving minus and here plus means cathode is at lower potential. Cathode means this one. Lower potential means let it be 3 volts. Anode is at higher potential. Then what happens to this diode? Diode will be forward bias. So whenever a diode is forward bias, what happens here? Whenever diode is forward bias, this diode behaves like a closed switch and a current will be flown through the diode through the load resistance RL. in order to produce an output voltage, where output voltage can be written as current into RL. So that's why here, as you can see, during the negative half cycle, an output voltage is developed. Okay. So during the positive half cycle, output voltage is 0. During the negative half cycle, output voltage will be developed. So this will be repeated for the next cycle also. So finally, we can say that the positive peaks are clipped away. Okay, in the positive clipper. This operation. So in the same manner, negative clipper. Negative clipper means this is the input signal and output signal will be like this. As you can see, this is a positive half cycle, negative half cycle, positive half cycle, negative half cycle, positive peak, negative peak. So negative half cycle, negative peaks will be removed here. This will be removed and this will be removed. As you can see here, this is the output signal. So how it happens, let us see by operation. So what is the change in this circuit here? When compared with the positive clipper, what is the change? Simply the diode is a reversed polarity. Diode is connected in a reversed polarity. Okay. Earlier the diode is like this. Now the direction is changed. Okay. Reversed polarity, right? That is a change here. So during positive half cycle, let us see what happens. So this is Vi and this is V naught. Okay. So whenever case, let us take the case 1, Vi greater than 0. Case 1. Vi greater than 0 means what happens? This is anode and this is a cathode. Anode is more positive when compared with cathode. So anode, this diode will be forward bias and it acts like a short circuit and the current will be flown by the diode through the load resistance RL in order to develop an output voltage V0. As you can see here, output voltage is developed. Okay. So this is the case 1 where Vi is greater than 0. Let us take case 2. Vi less than 0. Vi less than 0. Vi less than 0 means this will minus and this is plus. So anode is at lower potential when compared with cathode. Anode is at lower potential when compared with cathode means what happens to the diode? Diode will be reverse bias. Whenever the diode is reverse bias, what happens? It acts like a open circuit. It acts like a open circuit. Open circuit means it won't offer any current and zero current will be flown through the load resistance RL in order to produce an output voltage of 0 volts. So that's why here in negative peak the output voltage is 0. Okay. So and the next cycle will be repeated. Same operation will happen. So finally we can see that the negative peaks are clipped here. That's why it is called as a negative clipper. And here whatever we discussed here in the two clippers, that is ideal case. Ideal case in the sense the diode must offer 0 resistance in the forward biased manner and it must offer infinite resistance in the reverse bias manner. So we are not considering the barrier potential that occurs at 0 bias. Okay. And we are thinking that the diode is an ideal one in this particular operation. But here, if you take the practical case, what happens here is we need to consider this breakdown voltage or barrier potential that happens inside the device under 0 bias and that will be equal to 0.3 volts for germanium and that must be equal to 0.7 volts for silicon, right? So whenever under practical conditions, if you take this into the consideration, as you can see, this is a positive clipper output and this is a negative clipper output. As you can see here, during the positive peak won't be there. It will be equal to 0. But what is happening here under practical conditions, some non-zero output voltage is defined in the positive peak and that value will be equal to 0.3 volts for germanium diode and that value will be equal to 0.7 volts for silicon. Here also, second cycle. So instead of 0 here, a non-zero is defined and that value will be equal to 0.3 volts for germanium and 0.7 volts for silicon, right? So in the same manner, negative clipper also, under practical conditions, the negative peak must show 0 volts, but here it is showing some non-zero value. and here also second cycle. So non-zero value means it will be equal to 0.3 volts for germanium and it must be equal to 0.7 volts for silicon. Okay, so this is the waveform under practical conditions. Whenever you consider the barrier potential under zero bias into consideration, we need to take these graphs into considerations. Okay, next type that is called as a biased positive. Up to now, we had seen the positive clipper and negative clipper where total positive peak are clipped in some cases and total negative clips are clipped in some cases. Negative peaks are clipped in some cases. But here, in some applications, in my communication related applications, I need to remove a portion of positive peak. I need to remove a portion of negative peak. Okay, so for that type of applications, we need to construct one more type of clipper that is called as biased positive clipper. That means we need to provide some external battery voltage depending upon our application. Suppose if you want to clip 2 volts, we need to go for 2 volts battery like that. That will be seen if you go inside the circuit here. So here biasing is a process in which we connect a battery with the diode. Same thing is happening as you can see here. This is a resistor, a series resistor, and this is a diode. In series with the diode, here a battery was kept here. Battery, a voltage, a battery. Okay, and here a load resistance is there in parallel with this arm. This arm contains a diode in series with a battery. Okay, so what amount of portion to be clipped depends upon the selection of this battery. Okay, if you want to clip 2 volts a positive peak, we need to keep 2 volts battery here like that. Okay, so this is about the circuit. Simply the name is biased positive clipper. Biased in the sense, whenever you say biased, we need to bias with some voltage. So that's why here we are going for a battery which is connected in series with the diode. Okay, this is the load resistance RL and this is the series resistance. Here we will be giving the input voltage and here we will be taking the output voltage. These two terminals are related with the input. Okay, and these two terminals are related with the output. So this is the input voltage, which is a combination of positive half cycle and negative half cycle, right? Vmax and Vmin. And here this must be the output. My application here is I need to clip this portion of my positive peak. As you can see here, let it be 3 volts. Okay, so here I'm keeping it as a 3 volts and Vmax let it be 5 volts, right? For an example I am taking. Okay, so I need this amount, this particular portion above 3 volts and 5 volts to be, that particular portion must be clipped. Okay, so the circuit goes on like this. So here let us an example I am taking the battery voltage as 3 volts. As you can see here V is there. I am taking the battery voltage as 3 volts. Okay, let us go for the operation here. So this is the input voltage AC signal, that is the combination of positive half cycle and negative half cycle. I am considering the Vmax as an example. I am considering the Vmax as 5 volts in my operation as an example. Okay, so here first case 1, Vi greater than 3 volts. 3 volts in the sense here battery V. This is V. As an example, I am considering it as a 3. So whenever Vi is greater than 3 volts, so this is anode of the diode and this is the cathode. Here and separately I am writing here anode. So this is anode and this is the cathode. So whenever Vi is greater than 3 volts, I am considering this battery voltage as 3 volts. As an example, I am taking it as V is equal to 3 volts, right? Whenever Vi is greater than 3 volts, so here I am giving Vi as 5 volts. So whenever Vi is 5 volts, 5 volts means, as you can see, this is anode and this is cathode. Here 5 volts for anode. Okay, for cathode already it is a fixed voltage 3 volts. Okay, anode is at 5 volts, cathode is at 3 volts. That means anode is at higher potential when compared with cathode. Then what happens to this diode? Diode is forward bias. It acts like a short circuit. So it acts like a short circuit. So whenever it is acting like a short circuit, this can be represented like this. Okay, when it is represented like this, it acts like a short circuit. Okay, so if you observe the output voltage here, if you observe the output voltage, I'm explaining under ideal conditions. Under ideal conditions means I am considering this diode as an ideal diode. Okay, so that's why here, whenever the Vi is greater than 3 volts, anode is at 5 volts, cathode is at 3 volts, the diode will be forward biased. It acts like a short circuit. Okay, the arm will be looking like this. And what will be the output voltage here? Output voltage is equal to, this is connected across this particular arm. So what is the arm voltage here? That is 3 volts. Okay, whenever Vin is greater than 3 volts, as you can see here. So let us take this 3 volts here, reference voltage. Whenever Vin is greater than 3 volts, this portion. So what is happening here? V0 is equal to 3 volts. Okay, so V0 is equal to 3 volts means above this 3 volts, whenever input voltage is greater than this 3 volts, the output voltage is fixed as 3 volts, like this. Okay, so that is the case 1. Case 2, whenever Vi is less than 3 volts. Okay, whenever Vi is less than 3 volts, what happens? Let us see. So once again I am taking this diode. So this reference voltage I fixed the value as 3 volts, right? Vi less than 3 volts. Vi less than 3 volts means let the Vi value will be equal to 1 volt. 1 volt or 1 volt. Okay. Vi is equal to 1 volt. So Vi is equal to 1 volt means anode voltage. So Vi is connected to anode. So this is 1 volt and this will be 3 volts. Already it is a fixed. Cathode voltage is 3 volts. Okay. Whenever anode is 1 volt, cathode is 3 volts. Then what happens to this diode? The diode will be reverse bias. It acts like a open circuit. So whenever it is acting like a open circuit, what happens? This particular arm won't be there here. Why? Because it is open. This arm is open. So this arm won't be there. So what will be the output voltage? So whatever the node voltage here, same node voltage will be developed here also. So V0 output voltage must be equal to input voltage. Okay, output voltage must be equal to input voltage. What is the case here? Whenever Vi less than 3 volts, whenever Vi is less than 3 volts, output voltage must follow the input voltage, right? Okay, so V0 must be equal to Vi. Okay, so that's why, as you can see, whenever the input voltage is greater than 3 volts, the output voltage is 3 volts, right? Whenever it is less than 3 volts, it has to follow the input voltage. So that's why here, as you can see here, same input, same output is same as like input. Okay, so this is about the operation of the biased positive clipper. Okay, so whenever Vi is greater than the Vr, Vi is greater than Vr, okay, V0 is equal to Vr. Whenever Vi is less than Vr, V0 is equal to Vi. So we are taking the value as 3 volts as an example, and for first case Vi greater than 3 volts, I had taken the Vi as 5 volts, and I went for the operation, and I came to know that, and I proved that output voltage will be held constant at 3 volts. And in the second case, Vi less than Vr, where Vr we selected as 3 volts, and we selected Vi as 1 volt. And if you go for the operation, the diode is reverse biased, and this particular ROM will be opened, and the output voltage V0 will is same as input voltage. Okay, that's why above it is fixed at 3 volts, below it is same like input. Okay, this is about positive biased clipper. In the same manner, negative bias. Negative bias means here, as you can see here, negative peak is there. I want to remove a portion of this negative peak. So that's why here I am keeping a biasing voltage here in series with the diode, and the change in the circuit when compared with positive clipper is the diode direction is changed, the polarity is changed. Okay, and if you go for the operation here, as you can see here, I am keeping a negative battery here. Let it be once again minus 3 volts. Okay, so here I am writing minus 3 volts. Okay, minus 3 volts, and V max, let it be 5 volts positive value, and this is minus 5 volts. This peak, negative peak minus 5, positive peak plus 5. Okay, next, first let us see the operation here. So only change here is a negative battery is kept, and the diode direction is also changed, and we need the output to be like this, where the negative peak, a portion, I want to remove a portion like this portion I must not contain this portion. Okay, so that's why here whatever the portion, that depends upon the type of battery you selected, right? Okay, so here this is the input voltage and this is the output voltage. Okay, right? So let us take the case 1, Vi greater than V. V means the battery voltage. So here the battery voltage we have taken V as minus 3 volts. Let us go to the operation. Vi greater than V. Vi greater than V. Greater than V means let the input voltage be 1 volt, or let it be less than 5 volts. Let it be 1 volt. Greater than V means greater than minus 3. Greater than minus 3 means 1 is greater than minus 3, right? Or minus 2 also greater than minus 3. 0 is also greater than minus 3. So here as an example I am taking Vi as 1 volt. Okay, so 1 volt I am taking. So once again I am drawing the diode. So this is anode and this is cathode. So this is anode and this is cathode. So cathode is connected to input. Cathode is connected to input. So what is the voltage? We are taken an example, input voltage 1 volt. Okay, so anode is connected to battery, negative battery. What is the value? We are taken example as minus 3 volts. Okay, so anode value is minus 3 volts and cathode value is 1 volt. Okay, so anode is at lower potential when compared with cathode. Okay, anode is at lower potential when compared with cathode. Then what happens to the diode? Diode will be forward. Anode is at lower potential when compared with cathode means the diode will be reverse bias. Reverse bias means it acts like a open circuit. It acts like a open circuit. Okay, so open circuit means what happens to this particular diode? The diode opens here. Whenever it is opening, this particular arm will be useless here. Whenever an arm is there, shorted arm, whenever it is open, we can ignore that particular arm. So whenever this is open, this particular arm we must not consider whenever you are considering the output voltage. Okay, it is opening. Okay, so whatever the input voltage is given, the same input voltage will be absorbed across output voltage. Why? Because this arm won't be there, it is open. Okay, so what is the output voltage here? Output voltage is equal to input voltage. Okay, output voltage is equal to input voltage. Output voltage is equal to input voltage means 1 volt. Okay, generally we can write this equation, V naught is equal to Vi. So whatever the input is there, same will be followed by the output. So that's why here, as you can see, same input is same as output. Okay, so this will be continued. Suppose if you take one more value, negative value, let me take negative value here. Maximum value is -3 here. So here I am taking Vi is equal to -2 volts. Vi is equal to -2 volts. Earlier I had taken a positive value, right? Now I am taking a negative value which is higher than this battery voltage. Battery voltage is -3. So here I am taking the input voltage as -2 volts. As you can see, input voltage is connected to the cathode. So here I am writing the value as -2 volts. Okay. So anode is connected to -3, cathode is connected to -2. Okay. Anode is connected to -3 volts and cathode is connected to -2 volts. Okay. So anode is at lower potential when compared with cathode. Okay. -2, -3 is less than -2. Don't confuse here, it is a negative value, not a positive value. Okay. -3 volts is less than -2 volts. Or we can say -2 volts is higher than -3 volts. Okay. Then what happens to our diode? Cathode is at higher potential when compared with the anode. Cathode is connected to -2 volts. Anode is connected to -3 volts. So cathode is at higher potential when compared with anode means what must happen to the diode? Diode will be, what must happen to the diode? Cathode is at higher potential. Cathode is at, see here once again, Vi is equal to -2 volts and here battery is -3 volts. Okay. So -3 is provided to anode and -2 is provided to cathode. Okay, -2 is provided to cathode. So what must happen to the diode? So anode value is -3 volts and the cathode value is -2 volts. So cathode is at higher potential when compared with anode. As you can see, -2 volts is larger when compared with -3 volts. So that's why here cathode is at higher potential when compared with anode. The diode will be reverse bias and it acts like a open circuit. Okay, this will be open and this arm won't be considered here. Why? Because this is open, diode is open circuit. So the connection will be like this, some battery. So this arm, we can ignore this arm. So output voltage V naught will be equal to Vi. Same in the last case. So once again I am writing it as V naught is equal to Vi, where Vi is equal to -2 volts. Okay. First we had taken Vi is equal to 1 volt and we had seen that output voltage is equal to 1 volt and we had taken a negative value, Vi is equal to -2 volts and we had seen V naught is equal to -2 volts. So finally we can say that V naught is equal to Vi. Okay. So this is about a part of operation where I am taking a value Vi greater than V. Okay, second case 2. So here I am taking Vi less than V. Vi less than V. Vi less than V means, as you can see here, what must be the input voltage I need to select? So what is the battery voltage here? Minus 3 volts. Vi less than V. Vi less than V means, as you can see here, this is a minus 3 volts. And here what is the peak value here? Minus 5 volts. So here don't confuse here, minus 5 is less than minus 3 volts. Do you agree? It is a negative values, don't confuse here. Minus 5 is less than minus 3. Or we can say that minus 3 volts is greater than minus 5 volts. Right? So that's why here I am taking Vi less than V means I am taking the value of Vi as minus 5 volts. Okay. So anode is connected to minus 3. Okay, that is a fixed. And what about the cathode? Cathode is connected to minus 5 volts. Okay. Okay. So now what happens to the state of the diode? Let us see here. So anode is at higher potential. As you can see, minus 3 is higher when compared with minus 5. Okay. And minus 5 is lower when compared with minus 3. So that's why here anode is at higher potential when compared with cathode, means the diode is forward bias. The diode is forward bias. So this diode, as you can see here, the diode is forward bias means, so it is represented as a shorted wire. Okay, like this. So now what will be the output voltage? What will be the output voltage? This is the RL is across this arm. Okay. What is the output voltage here across this arm? That is nothing but the battery voltage. So in this case, we can write output voltage is equal to V, and here we have taken it as minus 3 volts. So that's why we can see here, it is fixed here. Okay, whenever Vi is less than V, output voltage is equal to the battery voltage, that is equal to minus 3 volts. Okay, so this is a biased negative clipper. Biased negative clipper, we have taken two cases for the operation, Vi greater than V, and second case is Vi less than V. Whenever Vi is greater than V, where V is the battery voltage, output voltage will be equal to input voltage. In the second case, whenever Vi is less than V, where V is the battery voltage, V naught is equal to the V, where V is the battery voltage. As an example, I have taken the battery voltage as minus 3 volts. First case, I have taken whenever Vi greater than V, I have taken Vi value as a positive value, that is equal to 1 volt, and I had seen V naught is equal to 1 volt. And in the sub case, like whenever Vi a negative value I have taken, whose value is greater than the battery voltage value. So here I have taken Vi is equal to minus 2 volts. And when I had seen the operation, the diode is open circuit for reverse bias, and the output voltage is equal to minus 2 volts. And in the second case, Vi less than V, V is fixed as minus 3 volts. Vi less than V means I have taken the Vi value as minus 5 volts. Okay. Whenever I taken Vi as minus 5 volts, minus 5 is less than minus 3. So what happens here? The diode will be forward bias and a short path is created here, and output voltage is equal to nothing but the voltage of the battery. So it is V naught is equal to VR. So that's why finally we'll be getting the output signal like this. Okay, so this is 5 volts, and this is minus 3 volts, and this is minus 5. So this is output voltage. Okay, so let me recap the things. First, I discussed about what I mean by clipper. And then I discussed about the basic types of clippers. One is positive clipper and negative clipper, and we had seen the operations also. And finally, other type of clippers where we need a portion of peak to be removed. In that case, we are providing a biasing voltage, so that is called as a bias positive clipper. We have seen the operation, and next we have seen the operation of bias negative clipper. Okay, so with this I conclude my video lecture, and in the next class we'll be discussing about the slicer circuit. Okay, thank you.